Everyone, welcome to my channel. So in this video we will learn about linear search, and I've just started this series where I'll be explaining the data search algorithms, the searching algorithms and the sorting, and some queries and questions based upon the DSA. So starting upon I'll be explaining the linear search, the algorithm, the time complexity, how it works, and then binary search, and then further sorting algorithms. So I'll be creating a playlist based upon these DSAs, searching and sorting algorithms. So if you have any query and questions related to DSA, do comment and I will be happy to create a separate video on each and every those topics. So let's start. So linear search basically, used to search a particular element in an array, and we do linear search in a sequential manner, also known as sequential search, where we start from one end of an array and search till the end of the array. Basically, it examines each element in the array until it finds the match, the element that we wanted to search in the array. Okay, so starting at the beginning of the data set until the end. So let's suppose we have an array. My array comprises of 6 elements. Let's suppose 22, 15, 9, and then 95. Last, okay, we can take at 5. Okay, so this is our array. Okay, so in this array we can see we have 7 elements. Size of an array is 7. So starting with linear search, or whenever we start a program, basically we should just write a algorithm, just a roughly algorithm or a rough program uh, that decide like how the algorithm or how this program will going to work. So I'm just writing a rough program of linear search. So step 1 would be, I have just created a location as default -1. Step 2 would be, I'm initializing I as 1 or 0. Step 3 would be, I'm going to repeat this loop while I less than n. N is basically the size of the array, and array of I not equals to search element. Okay, and we will do this I equal to I plus 1 till the time we are at the end of the size of this array. Step 4 would be, if step 3 is failed in any case, then if array of I matches the search element, then I will be providing the location or returning the location. Means we have found the location, and we can conclude that the element has been found at the specific index. So just also marking indexes 1, 2, 3, 4, 5 and 6. Size of the array is 7. Okay, and we have to go for the element 9. Okay, search element is 9. So like I already told you at the beginning of the video or tutorial, that linear search, basically known as a sequential search, we start from the beginning of the array. Means from the 0th index I'm going to check whether 9 is equal to array of 0th, means 22. If yes, then I will be returning the location or index 0. If not, then I will be moving towards next index I plus 1. If yes, then I will be returning the location index. If not, then second. Now in this case it has been found at the location 2, index 2, then I will be returning the location or index of this particular array, and I will be printing this index. In any case, let's suppose I'm going with this element 100. Okay, and in any case, if this element not found, then I will be traversing till the end of my array, and then I will be just returning that either element not found or element not available. Okay, so this is the linear search that basically we do in DSA. So let's just write a program and see how it works. So I'm going to use Java for the programming. So let's just create a new class. Public static and I will be taking array. So in my array, my elements would be okay. Now I'm going to pick one search element. So I'm going to go for 12 and int result index element, and I'm just going to create a new method, public static int linear search data. So this method will return the location of the array. Means this method will return index of the array, returns index of the array, and this method will take arguments integer array, size of the array and search element. Okay, so let's just pass and just call this linear search data. So I'm passing array, size would be array dot length and search element. Now I'm just going to create a for loop in I equal to 0, I less than size and I plus plus. In any case, if array matches the search element, then I will be returning the location, else I will be returning -1. Okay, now if result index element equals to -1, then I will be printing item not available or element not found. To be more meaningful, let's call it as search element not available or search element not found. Else I'm going to return the message search element found at index. Okay, now let's just run this. And we can see search element has been found at index 3. Now let's do this for 700. 700 is not present in our array, and let's just run this again. So we can see the message search element not available or not found. Now just going towards the complexity. So for the time complexity, the three cases that actually arises for each and every algorithm, every DSA query: best case, worst case, and average case. So best case would be the in case, like, let's just again. Okay, so let's suppose I'm going with element 22, and 22 is present at the first index or 0th, you can say. So in that case we get the search element in the first index. Then the time complexity would be the constant time, which means big of 1. So best case, we got element in our first index. Now the second case is the worst case. Worst case means the maximum time, like item is present at the last index. In our case, let's suppose I'm going up with the fifth element as my search element, or in any case, like the search is unsuccessful, I'm going with the element 100 and 100 is not present in my array. So in this case search is unsuccessful, and means we started from 0th index or first index and reached till n is like infinity. I don't know, like my size of the array is 6 in any case, or 10 or 15 or 20. So then the time complexity will be big O of n. Okay, so in this case my time complexity would be, this is the best case, this is the worst case, and this one would be the average case. Okay, now the average case means in this case we take a mid value like 95, I would take. Then it would be like 1 plus n divided by 2. Even though n has reached infinity, some cases it would reach the infinity, then it would be like then 1, and it is like n divided by 2, means it would be big of n, time complexity in this case. So in average case also time complexity would be big O of n. So overall we said the time complexity is big O of n in linear search. So linear search is the most simple, I would say, and most easiest algorithm we encountered towards this path of DSA. So we just do the sequential search, we go by one by one till the end of the array. We do for every index, we search for the every index whether or not the element is there or not. So it's quick, it is easy, but there are sometimes some cases when the size of array is large, and when you have to go till the end of the array. So in that case the size and the time complexity increases So in that case, we usually don't use the linear search algorithm as much, because there are some other algorithms we can make use of those algos. Okay, so guys, I think that's all from today. I've shared you the advantages and the drawbacks. Like advantages, if we again mention, linear search can be used irrespective of whether the array is sorted or not. You can see my array is not sorted, I'm just going for this search. It can be used of on arrays of any data type. Like I've gone with the integer type, you can go with string or any data type. Does not require the additional amount of memory, well suited for this algorithm for small data sets like 10, 5, 8, smaller data sets. Drawbacks are there, like linear search has a time complexity, average is like big off, and which in terms make it slow for the large data sets. And when should we use, like when you are going to use for these smaller data sets, when you are dealing with these smaller data sets, when you are searching for a data set stored in contiguous memory, sequentially you are going up with. So these are the advantages and drawbacks of linear search. And I think that's all for today. If you have any query or questions regarding the linear search, do let me know. And I think that's all for today. Thank you.